BIM is important to architects because it's the tool that we now use to illustrate our vision for a new building. When I started my career, we used pencils and pens, and that's evolved today to a computer-aided visualization tool, not only for the entire building, the overall building, but for the details of it. And it functions both in 2D and in 3D. If we had masonry-friendly BIM software, that would help us to draw. It would help the mason to understand what we have drawn. This is because masonry is a manufactured unit. It's a clay brick, it's a concrete block. It comes in defined sizes and defined shapes. The current BIM software has a limited palette of these, but it does not come close to the full array of standard sizes and shapes that the masonry manufacturers currently produce. So when we're drawing a building, if we can draw using actual sizes and shapes in the bonding patterns that they need to be placed in, if we can draw details, corners, intersections, tops and bottoms of things, openings, doors, if we can draw them accurately the way that the mason will actually build them, that helps us to have an accurate design. It helps the mason to understand our design. It helps the mason to take off in a more precise way his quantities not only of the overall masonry, but perhaps of each individual size and shape. In short, it brings the design a step closer to the job site and to the real world, the way the wall will actually be constructed. An architect chooses materials for design in an almost mysterious way. A material will come to the attention of an architect. It may be an ancient material, it may be a new material, but there's something about that material that's attractive to the architect. In selecting a material, though, the architect has to consider many, many different criteria. Where is the project? What's its latitude? Where's the sun? What's the weather? What's the use of the building? What are the owner's desires above all? What's the budget for the building? What are the capabilities of the local workforce? Is this material going to be subjected to use and abuse, hard knocks, or will it never be touched, only seen? Does it need to keep out the weather or not? Many, many criteria go into the design, and the architect needs to filter through all of those before making a final selection. The interaction between material suppliers and the architect can be improved by BIM if we had a tool which was more precise and which could more clearly communicate the architect's intention in a way that the manufacturer can understand it and can readily manufacture the materials that the mason needs. Masonry arrives at the job site in a completed unit form. It's a specific size, shape, color, hollow, solid, you name it. The manufacturer really needs to know which of those many varieties he needs to make. If I, as the architect, can communicate that to the materials manufacturer supplier in an effective manner, it's a win-win for both of us. BIM is the present and the future of the architect's toolbox. It's been with us for a number of years, it's evolved over those years, and it will continue to evolve in the years to come. It is at once a very, very complex and sophisticated tool, and at the same time, it's a generic kind of tool. There are simply far too many specific materials, hundreds, perhaps thousands of materials that we use and that we incorporate into a building for the software writer to develop really sharp utilities and instruments specific to that material. What has happened over a period of years is that various sectors of the industry will assist, they'll come forward and write better, sharper tools that are incorporated into that generic BIM program. These sharper tools assist all of us, the architect, the manufacturer, the actual tradesperson on the site, because they help all of us to communicate better.